This is my video submission for Lab 5 on first order sensors. We are going to be taking a look at an RC circuit with a resistor and capacitor connected in series, which has a first order response, just like a first order sensor. We will simulate this in MATLAB first, just to get an idea for what to expect. The voltage across the capacitor is plotted as a function of time here. The orange line represents 100 k ohm resistor, and the 10 k ohm resistor is shown in blue. So the larger the resistance, the slower the capacitor will charge. This is due to the restricted flow of electrons onto the plate of the capacitor by the resistor. So I have this circuit built on my breadboard with a 10 k ohm resistor and the 10 microcoulomb capacitor. I'm supplying the circuit with a from an I/O pin so I can toggle it between high and low, and then I have my ground connected to the negative terminal of the circuit. And then I'm going to measure using my analog pins the input supply voltage and the voltage across the capacitor. So going to my Arduino code, I specify my pins and calculate relevant parameters and variables for the program to run, and then I begin the serial port and then set the voltage to low for 5 seconds to decharge the capacitor. I then set the voltage to high and take readings from the supply voltage and the capacitor voltage and send it to the serial port, and then likewise setting the voltage too low. I'm going to go ahead and upload this, and we will open the serial monitor. And we should start to see a stream of numbers representing the supply voltage on the left and the capacitor voltage on the right. So you can see that there's a slight delay between the numbers, which is expected, just like in the simulation. So we can intercept this stream by using processing and create an oscilloscope-like visualization of what's going on in this circuit. So the main block that I added is this draw blank oscilloscope function, which is called once at the beginning right here to create the blank display, and then every time the position of the cursors get to the right side of the screen. So the blank oscilloscope function sets the background to black, draws all the horizontal lines, and draws the legend and symbols. So I'm going to go ahead and start the processing code. And you can see that we are displaying the voltage of the capacitor in green and the supply voltage in red. And you can see that there's a delay between the voltages as the supply voltage is stepped between 0 and 5 volts. So this is going to be saved as a CSV, which we can take a look at with MATLAB to take a look at the static image of what was happening. So as you can see, we're getting a high and a low for 1 second, just like in our Arduino specified, and at point 1 we're around 36% of 5 volts. So now if we go ahead and switch this for our 100k and we switch our resistor out, now with the 100 k ohm resistor in there, we can go ahead and take a look at the MATLAB output after I've already run the processing, and you can see that the response is indeed much slower, as now 10 tau is 10 seconds and tau is 1 second. The difference between the 10k and the 100k is just the amount of time that it takes to reach full charge.